Alright guys, so welcome back to the part 3, and in this part we are going to see how we can have some interesting shapes in our smoke simulation. Okay, alright, so let's first of all look like the issue that we get right away when we do a smoke simulation. Okay, so what happens in CG is, like, let's say this is our source, so we have make a kind of, like, a kind of density or VDB or something, and then we add temperature on top of it, and then due to temperature it gets carried away like this, and we get this static mushroom kind of smoke. Okay, so yeah, obviously it's fine, it's not bad or anything, but the problem is not with this mushroom, but the problem is with this new static smoke that we just keep on having, and this will just keep on rising, and we will just have a big mushroom, and then we have a kind of a stem. Okay, what we want is, we want to have even more details over here. We want to have more plumes, small plumes over here. Okay, so let's first of all really look like how do we even get this shape of this explosion. So once we know why this thing happens, we can break this look and we can come to this one. Okay, all right, so what happens here is, like, we have some density, we have some temperature. So let's say we are burning something, so the smoke, it starts rising. Okay, the temperature, it will make the smoke rise, and we have this one big plume. Okay, now the thing is, why do we get a plume initially, but then we won't get any plume? So why is it so that we get a plume at all, and then we get a stem like this? Okay, so let's talk about the anatomy of our smoke. Okay, so what happens in reality is, like, we have air in the surrounding. Okay, so we always have air in the surrounding, so we have this cool air. Okay, and it's having a very high density as compared to this hot air. Okay, then we have this hot air. Okay, inside our, so we have temperature over here. Okay, so because the density is low, it will rise up. Okay, and what happens now is, like, now there's a mix of this cool air and this hot air. Okay, so the hot air wants to go up, but the cool air is trying to like dissipate it. So now what happens, now there's a kind of friction which happens between both of them, and now that results into it makes our smoke change its path. Okay, it will start diverting, and it's going to divert the most from the edges. Anything in world, it will just have the most effect of resistance or divergence on the edges only. Okay, so now what happens, this smoke, it starts going down. Okay, it will, because this cool air, it's like pushing it backwards, and then what happens, it goes down, but then there's a pressure which is going up, so it gets mixed with it, and then again it rises. So that's why whenever we make any kind of silhouette of smoke or anything, we always make a puff like this. Okay, so that is why we make this puff, because that is how smoke travels. It travels in this vortices. Okay, so now the problem is, once this plume gets carried away, okay, it goes up, then we don't see any plume. Why? Because the air which was trying to act as a resistance, now there is no air. Now it's all a vacuum, it's all a suction force. Now it's all a suction, because now this big plume has already made the way for this new smoke, so we will just have a stem. So now, in order to break this look, what we can do is, we can inject new velocities over here. So let's say when we inject more and more new velocities, whose magnitude is more than the amplitude of this vacuum which is being carried up. Okay, so now what it does is, when there's a little explosion, so the smoke will move outwards, and then it will just then get carried away. So this way we have more details. So once there's a big plume, and then we always add some noise on the source, so it will keep on always it will always make some new plumes. Okay, which will then get carried away, but we'll always have some more and more details. We'll always have more details, so we will get a quite good, interesting shape like this. Okay, and what happens, which we are going to see in the next part. So then the next issue comes, then again we get a static shape. So now what we do, like, let's say after every 30 frames we add a big explosion again. Okay, so overall this will we will have a big plume over here, then we will have a big plume over here, and then maybe we will have a big plume over here, and then we will have a big plume over here. So we will get a very interesting looking silhouette of our smoke, and that is how we try to break that that non-random, that static look which we get in CG and which we don't really get in real life. So now let's just go into the tutorial and see how we can really do this. Alright guys, so welcome back to the scene, and now as you can see I'm just having this sphere and I've made a VDB out of it known as density, and now I'm having a density over here. So in the previous lesson we saw how we can use divergence to make cool looking explosions and everything, but because what we are after is like a continuous smoke simulation, so we are not going to do the animating everything, like animating the divergence and everything, because that is more or less suitable for the case of explosions. But because we want to have a kind of volcanic eruption smoke, so we just all that I've done is like I've just made this sphere, I've just stretched it out on these axes and converted it into a VDB, and now I'm having a density over here. Okay, now if I go to my .NET, I've removed everything else, and all that I'm having here is like density, temperature and the divergence. So just make sure you go to my first tutorial if you want to follow along. The second tutorial was just to explain the divergence. Okay, and now if you see we are just having this continuous smoke simulation. Okay, and you can see we are having density and temperature. Okay, and here I can just increase the resolution a little bit. I can set it to 0.1. okay, and now if we see we are just having this density and smoke, which is like the density and the temperature which is rising above. Okay, and also we are having this divergence which is like expanding everything. So if I like increase the divergence, it's going to expand everything even more. So as of now the way I like to work is like initially I will just keep the divergence to 0. I will just focus on the basic silhouette of the smoke, and once that thing is done, then I can just move on to the divergence and everything. Alright, so right now as you can see we are having a very static kind of smoke, and this kind of a smoke, as I already explained you, that is not really possible in nature. That is due to because this is more of a like vacuum smoke where there's like nothing which is, so whenever there's something which is burning or like in case of a volcanic eruption, there are a lot of small blasts which are happening, small blast, big blast, something is falling, rock is falling, which creates lot of turbulence in the source area, which always makes the smoke have multiple plumes. Here the problem is like everything is so it's so uniform that so why is it so that we are having this plume and then we are not having any plume? And the reason is because this plume as soon as the smoke rises, it gets in contact. So here the temperature is high, the temperature is low everywhere else. So when this low temperature meets the high temperature, when this high temperature meets the low temperature tries to dissipate the high temperature, and it acts as a as a air resistance. And what it does is it because the air resistance is like most in the middle part, so all the smoke it starts getting diverted in the sideward areas, and then what happens, that thing goes down, and again because this is also creating a kind of pressure and a vacuum, so again that smoke gets carried away on top of it. So we only get one mushroom and that's it. So what if we inject multiple velocities? Then what will happen is like if we inject, so here everything is getting carried away by this smoke, by this vacuum, but if we create strong enough velocities which are like more than the which has more magnitude than the vacuum itself, then we can get multiple plumes. Okay, so how we can do that? Okay, so now let's see how we can add some velocities. So first of all I will just add a points from volume, and basically I'm adding this points from volume is because I want more points inside this sphere. So we have this sphere. Okay, and I just want like some more points, so I'll just click on this mode shaded. Okay, so I will just want some more, points inside this geometry, so I can just click on this points from volume. Okay, and it's been set to 0.1, that is fine. And if I click on this jitter seed, if I increase it, then we can get like some random point position. Now I will add a point velocity. So this point velocity, as you know, if you have been into my flip course, like we use this to add some noise and everything, add velocity and noise on top of velocities. So instead of compute from deformation, I can just set to value, and I can just go into this curl noise and click on this curl noise, and if I like just click on it right now, so you can see we are having some velocities over here, and they are like they are like always animating like this. Okay, they'll just keep on animating like this. Okay, we can like increase the pulse duration to make them like little bit not that intense. We can also increase this sword size to have bigger and smaller noise. Okay, so something like 2 works fine. Okay, so this is mimicking the turbulence which is being caused in the source area. So let's say if there's a volcanic eruption, there will be a lot of small initial bursts which will just keep on happening on the inside the volcano. Okay, so obviously we cannot directly just use it because this is more of a point attribute, and this will work fine if you're using particles, if you're using flip, if you're using vellum or anything else, but this won't work with the cases of volume. So we need to rasterize it, we need to convert it into a volume. So add a volume rasterize attributes. Okay, and as you can see, the attribute which it's creating is V. So the P is position and the V is the velocity, which we are seeing over here. So if I go into this volume rasterize attributes, obviously if I come to this attributes, I can also click the P, so it's going to rasterize the position. But why do we want to rasterize the position? We don't want that, we want to rasterize the velocity. Okay, and as soon as you do that, you can see there's something really strange about it. And the thing is, like, here we were having really small sphere, but now the volume rasterize, it got really large, and that is because it's depicting the particle scale to be 1. We just need to bring it down, so 0.1 will just work fine. So this is our original sphere, and this is our volume which is created by it. You can even put it even lower, but 0.1 will just do fine. And again, you can just connect the size, you can put it to 0.05, or you can even go lower. You can just connect the size with the original simulation size. Okay, simulation resolution. And now if I play it, you can see we are having something over here. And this velocity, okay, so here you can see it's a point attribute. Now it's getting converted into a volume attribute, it's getting converted into a volume, into a field. Okay, now obviously I don't need to I can do that, I can just merge all of them into one, or what else I can do is I can just keep them separate. So here I will call it well. Okay, so I'll copy this now, Control C, and I'll go over here. So the reason I did this because I want to keep different volume source for everything. So this is density, and maybe I'll color it in red, or maybe I'll try to color it a smoke color, so smoke is like grayish. Okay, and now I will add a merge. Okay, and I'll put it over here, and I will just duplicate this density, put it over here, and now I will give it a path of my velocity field. Okay, well, and I'll just remove everything else. I'll just keep one thing. In the source volume, I'll keep it to V, and the target field, I'll put it to well. Okay, so now let's see if it's working, and obviously I'll call this well. Okay, now let's see if it's working or not. So let us just do a quick sim and see how it's looking. Okay, so we have got something like this, and yeah, it's looking fine and everything, but the problem is the velocity is way too much, and you can see the smoke is coming to a halt after some time. So why this thing is happening? Let's just take a look. Okay, so in order to fix this, let's go back. Let's go to this first of all. So why the smoke is coming to a halt, and that the reason is also one more thing that I'll explain you later. Okay, so the cooling rate is set to this 0.459. so in the cases where the smoke has to just rise infinitely, I try to keep my cooling rate really low, so this way my smoke, it will never get cooled down. It will just keep on rising and keep on rising, it will just keep on rising all the time. Okay, so it's not going to come to a halt. And if I have to if it's going out from my camera, I'll just delete it after some time, but I don't really want to stop it at any position. Okay, so that is one thing. Second thing is okay, so now you can see, now we are getting this shape. Okay, and the second thing is right now the buoyancy, it's kind of looking really low. The smoke is not rising that fast enough. Smoke is not fast enough, so I can just put the buoyancy scale to 0.01. And now if we see sorry, not 0.01, I mean 0.0, maybe 0.1. 0.1 is fine. Okay, now let's see. Okay, so you can see the change now because there is velocity, so it's it's depicting those small internal breakups in our smoke simulation. Okay, so there are small breakups which are like happening into our simulation. Okay, and this is like creating a lot of interesting motions. Okay, so not everything is like just getting pulled right away. Okay, things are getting pulled right away, but there are also velocities which are like higher than the magnitude of the vacuum which is being created by this temperature. So it's like it's counterbalancing it. Okay, and we are getting this cool looking smoke. Okay, so that is one thing. Now one thing that I need to tell you, so if you go into this Pyro solver and if you go into this advanced tab, make sure if you go into this advection, so make sure this modified this advection scheme, instead of this modified Mac Cormac, it's set to BFECC. So this will tend to produce more better smoke simulation. Okay, it will create better velocity fields and it will just basically have more details in the smoke. So I've tried it a lot of times. It's little bit slower, but it's worth the wait because it gives like heck lot of details to your simulation. Okay, so as you can see, we have got something like this, and this is looking fine and cool and everything, and I think that is it for this part. But there's one issue which we are going to fix in the next part, and the issue is like you can see again, like even though we have got a cool looking simulation where we are having some breakups, but overall shape of our simulation, it's looking very uniform. Okay, and there's like no big breakups. Okay, so what I want is I want a good silhouette, like initially the one which I got initially, something like these two plumes which I got initially, I want that to happen, like I want that to keep happening after some frames, so I can have little bit bigger explosions after every maybe 30-40 seconds, or sorry 30-40 frames or something, and then I can get even better looking smoke silhouette. Okay, so that is one thing. Next, one thing which I forgot to turn on is like the divergence. So if I go into this divergence, maybe if I put it to 5, so now our smoke is going to expand more, but it also comes with the cost of different looking simulation, because it's not just expanding the density, it's also expanding the temperature, and it's also expanding the velocity field. So it's going to expand almost everything with itself. So it might change few stuff, because if it changes buoyancy, it will also, like if it changes the temperature, it's also going to affect the buoyancy. Things are going to rise faster, so you might need to play with the buoyancy in order to like control everything. But I think right now it's looking fine. Or maybe if you want a more explosive kind of simulation, you can put it to even more, so 15 or so will also work fine. So let's see how it's looking. Let me just make a preview first. Okay, so if you see, we have got something like this, and you can see like we are having these breakups in the smoke, but the problem is like the smoke is rising like way too fast, so we need to bring that down. Okay, so let me just go here and like change the buoyancy. Okay, so as I told you, if you increase the expansion, things are going to change a lot. So I can just go over here and maybe I'll just decrease it by half times, and also now I need to increase my velocity. So if I put it to 2, and now let's see how it looks. Alright, so we have got something like this, and now I think it's looking really good. So you can see we are having this large scale noise which is like moving the smoke sideways. The only thing which I'm feeling is like the swirl size is like little bit too big. Right now you can feel it's like it's acting more as a wind kind of something. Okay, so I don't really want that, so I can just go back, okay, in my in my noise. Okay, and in this noise I can, instead of this swirl size set to 2, I can just put it to 1. Okay, and in the pulse duration I'll just set it to maybe 1 in order for it to like increase, like change rapidly. Okay, now I'll just do one more simulation and see how it's looking. Okay, so now I've got something like this, and I think now it's looking almost perfect. The only thing which I'm feeling is like maybe the velocities could be little bit more intense in order to break up the smoke even more. So I'll just try that, and I'll just resume the simulation, and we will see how it looks. Alright guys, so we have got something like this. I've done a high res simulation, and we are having something like this, and I think this is like looking really good. So this is depicting how a real smoke or volcano eruption smoke will look like, and it won't be something like, you know, some smoke which is just straight going in a plain path, in a straight path. We will always have these small little explosions, small little plumes. And right now we haven't added any vortex confinement, so once we add vortex confinement we'll get lot more details. But this is, you can see, a plain simulation with just some added noise, and that is it. Now in the next part we are going to look at how we can create some more extra explosions to, you know, break up the shape even more, to make it look like, you know, it's having we are not having just simple silhouette, we are having like some more details to it. Okay, so let's just meet in the next part. Bye bye, take care.